Okay, taking a look at page 17, 18. Let me get down to the end of these. All right. So page 17, 18. Within the first four, which one do you want to see? First four, which one do you want to see? Yeah. 2. All right. Problem number 2. So we have 2 over the square root of 3. Remember yesterday we said we don't like to have the radical on denominator, so we have to rationalize it. So I'm going to multiply both top and bottom by root 3 in this case. So that gives me 2 square root 3 over square root 9. Square root 9 is 3. Check to see if those can reduce. If not, you're done. What about anything up to the first 8? First 8. Yes. 3. So 1 over square root of 7. Again, we're going to multiply both top and bottom by root 7, So I get 1 root 7 on top, which is just root 7, over root 49. Root 49 is the same thing as 7. Nothing to reduce outside. Stays as is. Yeah?
Oh, sorry.
Any other questions up to number 8? 8? I get 2 over square root of 11. Okay, square root of 11 is not a perfect square. I'm going to multiply both top and bottom by square root of 11. So I get 2 square root of 11 on top over square root of 121 on bottom. Square root of 121 is 11. Check to see if outside I can reduce. I cannot. Anything up through... 2 square root of 11 over. Yeah, but one's a radical and one's not. So the radical is being treated like x. You can't multiply inside to outside. It's outside to outside or inside to inside. Cool. 7. 81 is a perfect square, so the answer to that's just 1 over 9. So there's nothing to do on that. Anything up through 15? Yeah. Okay. Number 5, we have 15 over square root 5. Multiply top and bottom by root 5 and root 5. So on top I get 5 square root 5, or 15 square root 5. Bottom I get square root 25. Square root 25 is 5. And then on this one you do have to reduce it. Outside to outside, 15 over 5 reduces to 3, and then the root 5 comes along for the ride. Number 6, that was also asked for. We have 42 over square root 7. We'll multiply the bottom by root 7 and the top by root 7. So I get 42 root 7 over root 49. Root 49 is 7. And then I can reduce 42 and 7. 7 goes into 42 6 times. So I get 6 root 7 for an answer. Question over here I saw? No? Anything else up through 15? Yeah. 13.
Yes.
13, good? All right. 13 and then 15. Okay. 13, I have 8. Are you sure you want 15 as well, you said?
No, sir, I did 15. I meant
12? All right. I'll write them both up there. All right, this will be good for the front page. So I want that radical moved. So I'm going to multiply both top and bottom by root 2 and root 2. So on top I'm getting 8 root 2 over 3 times root 4. Root 4 is 2, right? So this gives me 2 for an answer, so that's over 6. And then I can reduce 8 over 6 to 4, and then root 3, or 4 root 2 over 3. So 8 over 6 reduces to 4 over 3. On bottom, is square root 16 a perfect square? Yes, it is. So I get 1 over 12. So I don't have to do that because I had a perfect square already on bottom. All right. 16 through 35. Questions on that backside? Yo.
Mister, can you do 11 for me, please?
Oh, sure. 225 is a perfect square. So it's 15. So the answer to that's 1 over 15. So 225 is already a perfect square. Okay, on the backside. On the backside, take a look at the backside. Anything you need me to cover on the backside? So a lot of that's review. 18. Review what we've been doing. Okay, so number 18. You have a negative and then a square root of 100. Well, square root of 100 is 10, right? And the negative has to come along. Anything else up through 35 on the back? Yeah.
23.
2, 3. Number 23. I have a negative out front. 81 m to the 64. Okay. So the answer is going to be negative. There's the negative out front. Square root of 81 is 9. This is a perfect square because it's an even number, right? So what's half of 64? 32. So the square root of m to the 64 is m to the 32. So that's my answer.
You want to do square root of 64?
No, because it's an exponent.
Oh, right.
When it's an exponent, you only take half to take the square root. If it's a base number, you don't. What else do we have on that back page? Go ahead. 33? 33. Let's see. Square root 36, x squared, y to the 6th. Okay, is 36 a perfect square? Yeah, 6 times 6 is 36, so that gives me 6. Is x squared a perfect square? What's the square root of x squared? X. Is y to the 6th a perfect square? Yes, it's even, so what's the square root of y to the 6th? Y to the 3rd. Okay. What else do we have up to 35? 34? 34. Square root of 12. X to the 20th y. Okay, 12's not a perfect square, but a perfect square times another number would give me 12. 4 and 3, where 4 is a perfect square, right? Okay, so let's break 12 up to this. And then x to the 20th is a perfect square, so nothing to do there. But y is not. Okay, so what's the square root of 4? 2. What's the square root of x to the 20th? X to the 10. And then I'm left with this in the radical. What else we see?
25.
25? Okay, everything under there is a perfect square. Square root of 121 is 11. Square root of x to the 14th is x to the 7th. Square root of y to the 6th is y to the 3rd. And we're done. Yeah. 29? Square root of 180. Okay. So I'm sure a perfect square times something will give me 180. So let's think of the perfect square. So we have 4, we have 9, we have 16, 25, 36, 49, 64, 81, 100, 121. That should be enough. Let's see. Something time. If you have calculators, this would be a good time to have them out, please. Okay. 121 times something is not going to give me 180. 100 times something is not going to give me 181 times 2 is 162, so that's not big enough. 3 times 164 is too big. That would be 192. 49 times 3 is 150. 49 times 3 is 147. Too small. 49 times 4 is too big. About 36. 180 divided by 36 is how much? It's 5? Oh, okay. So 36 times 5. Is that okay? Feel okay with that? What's the square root of 36? 6. 6 square root of 5 is my answer. What else do we have?
Did you do 25?
I think I did. Let me go back and take a look. I think I have it up there. Yeah, right over there.
Alright.
24.
24.
I don't think I did.
Page 24,
24. Let's see. 49. A to the 4th, B to the 12th. Is everything there a perfect square? I know 49 is. What about A to the 4th and B to the 12th? Are those both perfect squares? Yeah. Okay. So the square root of 49 is 7. Square root of A to the 4th is A to the 2nd. Square root of B to the 12th is B to the 6th. Anything else you want me to go over? Yeah.
30.
30. You got it. Good one. 30 looks simple, but I could see how you could get caught up on it because A to the 3rd is not a perfect square, right? So let's change it to A to the squared times A. If I multiply those back together, I get A to the 3rd. Now, the square root of A squared is just A. What's left under the radical sign? A root A. Yeah. 34. Did I do 34? There it is. 34 is right there.
Oh, okay.
Thank you.
And then let me do 32 because I can see how that might get confusing. 32, we have the square root. Well, okay, 30 or is 45 to the 7th under the radical. Well, I know that 9 times 5 is 45, and 9 is a perfect square. Agreed? And then if I'm going to break A to the 7th and make it a perfect square, I need A to the 6th and A being multiplied together. Is that all right? Square root of 9 is 3. Square root of A to the 6th is A to the 3rd. Then I'm left with 5A underneath the radical. Anything else you'd like to see? Yep. 27. Okay. 125 is the same thing as 25 times 5. Okay. And then the square root of 25 is 5, so I get 5 square root of 5 for an answer. We A-okay? Going once? Going twice? Oh, okay, thank you. We all good? Happy? If you would, make sure your name is on that. Anything else you're submitting, make sure your name's on. And then go ahead and turn it on in. Pass it on forward, please. We try. All right, let's take a look at notes for today. And I gotta kind of go. There's not a lot, but I'm gonna go a little slower through them. So I want to make sure you're finding it. So we're gonna talk about like what happens when we add and subtract these things and how do they work. So when we multiply outside numbers and multiply inside numbers. So does it make sense when I say outside numbers? Do you understand what that means as far as a radical goes? Outside the radical. Inside numbers are inside the little radical or the little house. Okay, so I'm going to show all the steps that go to it. So I get 4 times 3, which is 12. And then I have square root, and I multiply inside. What's 2 times 2? 4. Is the square root of 4 a perfect square? So what's the square root of 4? 2. So I get that, which is 24. Okay. Where did all the radical goes? Where did the radicals go? Because they made it a perfect square, you take the square root and they go away. And then letter B, outside to outside, so I get negative 2 times 4, so that's negative 8. And then inside I get 3 times 15, which is 45. Is 45 a perfect square? No. But is there a perfect square times another number that would give me 45?
Yeah.
9 and 5. And 9 is the perfect square. Great. So I get 8. And then I'm going to break this up to square root of 9 times 5. Is that okay? Square root of 9 is what? 3. 3 comes out. Okay? And then negative 8 times 3 is negative 24. And then I have square root of 5 that's still inside. And we'll stop. Can you make sure that makes sense? That's quality. You guys are looking at that. I'm going to crack my back. Jake, you're on your phone way too much, buddy. Okay, sorry about that. It's the only reason I teach. Because I don't have desks like this in the regular workforce. How do I get 24? Square root of 9 is 3. 3 times negative 8. Are we good so far? Okay, you ready? I'll wait for you.
Are you good?
Are you good? All right. For letter C, I'm going to distribute. So I'm going to multiply here and here, and then here and here. So 2 times 3, or 2 times 3 root 2 is 6 root 2. Okay, because the outside gets multiplied, plus 10. Can I break square root 2 down any further? Hang on. Can I break square root 2 down any further? No. So this is my answer. Go ahead.
Why did you do a multiply by the 5 instead of the 2?
Oh, this 2 was not inside of a radical, so it's only, you can only multiply inside to inside, and being distributive power is multiplication. It can go multiply outside to outside or inside to inside, but you can't go multiply an outside number to get an inside number. And that one just, there was nothing left to combine, so we couldn't add them together. May I move to the next page or the next slide? I guess it's your same page, right? Okay. All right, so when we add or subtract radicals, they have to be the same radical to add together to create like terms. You treat radicals like x and y. If you had 6x plus 3y, you can't add 6x and 3y together because they're two different things. It's the same thing with radicals. If you have the same radical, you can add, and you just add the outside. So 3 plus 8 is 11. The square root 2 comes along for the right. It acts just like a variable would act. So this is just, you're counting them up. How many root 2's do I have? I have 11 root 2's. Okay, how do you know that? Well, I had 3 root 2's here, and I had 8 root 2's here, so when I counted them all up, I had 11 root 2's. Okay? Letter E, I can't add them together as they sit, but can I break 8 down into a perfect square times something else? 2 times 2 is 4, times 2 is 8, so I get 3 root 2 plus 6 times 4 times 2. 4 is our perfect square. 4 times 2 is 8. So what is the square root of 4? 2. So I'm going to rewrite this just to bring it down. Everyone feel good so far? So the square root of 4 was 2, right? That gets multiplied with that 6. Look at that. I now get a 12. Let me pause there. It's not done, but let me pause. Make sure you feel comfortable with what I did. Make sure you understand where that 12 came from. Yeah.
On the previous problem, letter D, you just added the 3 and the 8.
Yep, outside to outside.
But this one's also outside to outside with a 3 and a 6. Okay.
But I have unlike radicals. So remember I said radicals are like x and y's. So root 2 and root 8 are different, so I can't add them together. But I could break root 8 up to 4 and 2. That becomes square root of 2, or square root of 4, which is 2. 2 times 6 is 12. That's where it came from. Now everything's the same here, so now I can add. How many root 2's do I have? I happen to have 15 of them. Okay. What about letter F? I have a root 45 and a root 20. They are not the same radical. Agree?
Yeah.
But I might be able to break root 45 down. What does root 45 break down to? 9 times 5, and 9 is a perfect square. Agreed? And then minus. What about root 20? What can I break 20 down to? 10 times 2, but I want a perfect squares, and 10 and 2 are perfect squares. What's another perfect square? 4 and 5, right? You feel comfortable with what I have written there? Okay. What is the square root of 9? 3. So 3 times that 5 gives me 15 square root 5. Minus, what's the square root of 4? 2. Negative 2 times 2 is negative 4 root 5. It's not done yet, but you would see why that happened that way. Took the square root, and then I multiplied whatever the square root of that number was to the outside. I have 15 root 5 minus 4 root 5. 15 minus 4 is 11. So I get 11 square root of 5 for an answer. Yeah.
If it was like 15 root 5 minus 4 root like 3 instead of.
Then that would be your answer. You can't combine them together as far as the addition goes. Okay, good question. Good question. May I advance to the next slide? We good? All right. So remember that all factors get the exponent. Okay, so I have 2 root 2 as a quantity. It's grouped together, raised to the second power. So that 2 comes here and here. So I get 2 squared, which is 4. And then inside here, root 2 times root 2 is root 4. Root 4 is 2. I get an answer of 8 here.
Could you also break down that outside? Oh, because time is squared.
And then letter H, I'm going to square the 25, and I'm going to square that, so I get 25 square root 9. Y'all see where the 25 came from? Because I squared 5, so 5 squared is 25. And then I squared root 3, so root 3 times root 3 is root 9. What's root 9? 3.
So when it's in the parentheses, does that mean that you're always going to get?
Goes to both. If you had 5 root 3 and the root 3 was the only thing squared, you would just take care of the root 3. But being that's grouped together, that means you have 5 root 3 times 5 root 3. We're on the back side now, huh? This is the last slide, but it looks like there's 9 things in there. Okay. They might be too small to see, so make sure you have plenty of room below that if you need to rewrite them, please rewrite them. So, okay. I have root 48 minus 2 root 12 plus 3 root 5. So I think 3 root 5 is broken down as far as I can go. What do you think? Because 5 is just 1 times 5, so I can't break that down. What about 48? 48, what perfect square? So 8 does, but 8's not a perfect square. 4 goes into it, but I think there's a bigger perfect square that goes into 48. 16. So 16 times 3 is 48. Do you agree with that?
Yes.
16 times 3 minus 2. And then 12 breaks down to what times what? 6 times 2, but I don't have a perfect square with 6 and 2. 4 times 3. And then 3 root 5 doesn't break down, just stays as is. Do you feel comfortable with that? Square root of 16 is what? 4. So I get 4 square root 3. Square root of 2, or square root of 4 is 2. multiply times that outside 2. That becomes 4 root 3. And then plus 3 root 5. Those are opposite signs, so my answer to this problem is just 3 square root 5. And I stop. And the blue or the green?
Blue.
Okay, so are you okay with 4 root 3, the very first one? The second one, are you okay that that's minus 4 root 3? And then the third one is just plus 3 root 5.
Okay.
And then I have 4 root 3 minus 4 root 3, so those are the same thing, so they cancel each other out. And then the only thing I have left is 3 root 5.
Okay.
May I move forward? Okay. It's a nice baritone go. Good. All right, second problem. Looks like I'm going to use my distributive property. So multiply here and here. So I multiply outside to outside and inside to inside. So I get negative 24 root 18, outside to outside being multiplied, plus negative, or I could have just put minus. I could have made this just a big minus sign right here, because plus, negative, and minus is the same thing. And then outside to outside, inside to inside, minus 48 root 6. Can I break root 18 down with a perfect square? 3 times 6 is 18, but is something else? 9 times 2, and 9 is perfect square, right? Negative 24, 9 times 2, and then I can't break 6 down, so I think that's just going to stay as is for right now. Okay? What is the square root of 9? What's the square root of 9? 3. 3 times negative 24 is negative 72 root 2, because that's still there, minus 48 root 6, and that's my answer. I won't get any further broken down than this. Well, problem number 8. Finishing up on number 2. Is there any questions on number 2? Number 8, how many 5 root 2's am I multiplying together? 2. 5 root 2 times 5 root 2. So because it's grouped, this 2 comes here and it comes here. So I get 25 root 4. Root 4 is 2, so this comes out to an answer of 50. I got a silly memory that keeps playing in my head. So I was 5 years old. I was with my grandma at the grocery store in New Jersey. My parents used to send me and my sister back to New Jersey every summer. But I was with my grandma at the grocery store. And I don't know why the heck this is kicking in my head, but I can see it like it was yesterday. You know how like sometimes when they close off one of the shopping cart things, they put a little chain across? So you have that little O-ring where you clip in? I remember I got my finger stuck in it, and I couldn't get my finger out, and I remember just like this panic of, like, I'm going to be left here forever because clearly my finger's not coming out. And I remember that they put a little soap detergent on to make it slippery, so my finger slipped out. And I keep playing that image over and over in my head. I have no idea why something from 1975 would be coming back into my head right at this moment.
Oh, is it like the tide stuff? Is that why? Like how people are biting the tide, like the tide?
Boy, I have no idea. I have no idea. I don't think we had Tide Pods back in the day. We had like 2 different soaps. I know, but it was my main thing was my finger being stuck in this little O-ring and couldn't get it out. And so I don't know why that kicked into my head. Yeah.
How old were you?
5. So 42 years ago. Like, make that work. Like, why is that kicking into my head right now? Like, hey, remember this? I mean, that's what it's like in my head. So that's what's going on in my head right now. I don't know why.
That's what happens on me.
All right, number 4. Let's move on. I'm sorry to inundate you with the weird thought process of stirrup.
Yeah, I was actually counting.
All right, I'm gonna multiply this to both of these. So I get 24 root 50 minus 8 root 25. And let me just pause there. Make sure you understand why all of that's taking place.
So you multiply.
Outside to outside and inside to inside. I'm just distributing 4 root 5 to both.
Okay.
All right, does 50 break down to a perfect square times another number? What do you think? Can I break 50 down to a perfect square times something else? Yeah. 25 times 2. Great. So I get 25 times 2. And then 25 breaks down to what? Root 25 breaks down to what? 5. And that 5 gets multiplied to the 8, so this becomes minus 40 so far. Is that okay so far? Okay. And then I get square root of 25 right here, which is 5. And 5 times 24, 120. Did I do that right? 5 times 24 is 120. I'm left with a root 2, though. And then this is minus 40. And that's as far as I can go. Square root of 25 is 5. And then negative 8 times 5 is 40. Yeah.
Couldn't you subtract 40 from 120?
I can, but the 120 has a root 2 attached to it, so they're unlike terms. So if it came out to 120 minus 40, then absolutely. But because I have 120 root 2, it doesn't allow me to subtract that. All right. Let's see if you can follow me on this one. What do you think? I just was quiet on that one. See if you can follow my method to my badness.
Where does the 4 go? 4 times 3. Oh, it goes to 12.
Yeah, because square root of 4 is 2. Anyone else get their fingers stuck in some? Yeah, that.
My
Oh,
brother
stuck in one of
got,
those little Chinese things.
my brother got his finger stuck in one of those little holes in the wall at Chipotle.
Okay, so I'm not the only one. So you need to remember this day. When your brother turns 47, which I'm sure it's many years from now, you need to say, hey, do you still remember this? And just see if you can mess with him. Like, I had this math teacher who's, now probably, drooling on himself and can't remember who he is. But that would be me. Because I imagine your brother's how old? 10? Oh my gosh. So in 37 years, oh my gosh.
Set a reminder.
That puts me way too old. 37 added to 47. Oh my gosh. You'd still be alive.
84.
I'd be 84. If I'm still teaching at 84, I might be teaching your grandkids in a way.
That'd be so cute. Oh,
You guys have still Mr. Sturb. Ask him about when he got his fingers stuck. I mean, what?
that's crazy.
Do you ever teach kids like that and have like their kids and then go to
I haven't been. So, I've been teaching for 22 years. So obviously, kids that I taught now have their own families. But I didn't live. I still don't live there. Like that was when I lived in Vegas. So I guess if I still lived in Vegas, yes, I could have had them.
How long have you been here?
I've been here in Colorado for 13 years. I've been here for 4. I hope to stay here for the rest of my career, which is like another 6 months or so.
Mitch, you think you're that old?
I have 13 more years to teach, and I'll be done. No, it goes like that.
Because of
You
people
want
like
to know
you.
how quick 22 years of teaching went?
Because of people like you.
Like, where'd it go?
Oh.
All right, let's take a look at this number 6. I have square root of 16, that's 4. Square root of x to the 6th, that's x to the 3rd. Square root of y to the 4th, that's y to the 2nd. On bottom, I have square root of 25, which is 5. I have square root of x squared, which is x. And on bottom, I have square root of y to the 4th, which is y squared. 4 over 5 does not reduce. Tug of war with the x's, top wins by 2. Tug of war with the y's, they tie, so they cancel out. So here's my answer here. So I just went through and literally just treated that radical on each one of them because it was a bunch of perfect squares. Yeah, when I first started teaching, I still had a chalkboard. I'd get home and I'd have chalk all over my slacks. And oh, I've got to wash these again. Does he? Must be old. Who's your teacher? All right. Let's look. I'm moving down to number 8. Let's move that up there a bit. I'm going to skip number 7 because I can't see it anymore. And then I'm almost out of time. So let's look at number 8 as my last one. 108. Let's see. If you have a calculator, it'd be great. 108 divided by 16 is what? The reason I'm choosing 16 is that's a pretty big perfect square. Okay. Oh, wait, no. That's not going to work. 9? 9 work? 108 times, or 9 times what is 108? 9 times 12? What about 36? Does that work? 108 divided by 36? 3? Oh, let's do that. 108 is 3 times 36. And then I have x to the 8, that's a perfect square. And then down here I have plus 2x to the 4th. 72 breaks down to 36 times 2. Square root of that is going to give me 6x to the 4th, and then I'm left with root 3. And then square root of that, that's 6, 12, x to the 4th, root 2. And this is what I want to give you for your assignment for tonight. Let's do page 19 only, just the front. Just do page 19 only, the front. So it's 1 through 12, okay? And we'll go over that tomorrow.
All right, let's have a good day.
Okay, watch out for those eye hooks out there. You get your finger stuck in it, get a little detergent.